So this is take two, because you always find something at the end. You're like, man, I need one more diagram. So this one's really about moving graph data to a rectangular data store. And that's really moving graph data into a reporting database or some type of relational data store. So graph data really has its uses. There are some really cool things you can do with a graph-oriented schema. And not the schema I'm going to show you here, but there's some complicated or sophisticated graph schemas where you can do things that are really hard in a relational database. But in the end, it always comes down to, oh, thank you for doing that totally awesome thing with your Customer 360 project. How are we ever going to join that data to anything else? How are we going to generate reports? How are we going to use it for training data for machine learning? All that kind of stuff. So I'm just going to use a super dumb, and this has major shortcomings as an example. Basically, we have a person at the root of our graph object, because we have a root in this case, and we've got single cardinality mailing and billing address, and that's two, a vertex or a node for a person, and a vertex or a node for address, and then we've got two relationships or two edges for mailing and billing address. And then you can have multiple, then we have phone number as a relationship, so these don't go too deep. So some of this example, it really should go one more deep, but we're going to live with it. And on the phone case, I haven't decided what the edge cardinality. Let's say you can have multiple phone numbers, because that makes sense. And they all have the same meaning. We don't have the notion of a billing address or a mailing address, so we're just going to leave those as a multiple cardinality edge, whereas the mailing and billing are each single cardinality, but they each represent a relationship between the same two entities. So the cool thing about a graph database is the edge can have properties. So like on the phone number here, or all any of these, you might have like, when did this person get this phone number? Because this phone number might be shared across multiple people, and the same with an address. On the person, you might have a name and address, first name, last name, and on the address, you'll have like delivery address, city, state, that kind of thing. You could have last updated date on any of those kinds of things. Now, when we go to a reporting tool, what we really want is a denormalized reporting thing that's optimized for consumers, right? So this is a producer or business-oriented schema, and down here we want a reporting-oriented schema. So in this case, what we'd really like, if I had two addresses, billing and mailing, I'm going to have two rows in the reporting database. The same address will be here twice, the same person will be here twice, and you'll see a billing address and a mailing address in the Y column. Now for phone numbers, I didn't put any attributes on the phone number that I cared about, like when did this person get this phone number. So instead, I just have a row for each person phone number combo. So if the person's got 3 phone numbers, there'll be 3 of that person here. All right, so that's what I want this to look like. Now, there's a couple ways we could do this. One of them is to do the very graph-like way, which is query the root object and find everything related to it. For this graph, it's actually not too complicated. You could run a query for a person, find all the relationships off a person and all the addresses and all the phone, come back with one big object. It would be probably a JSON or a nested document object. So we're not in record format like we need for our database. And if the database had things like a bank account, and that person was tied to a bank account, and the bank account knew about the phone number, now you got to decide how deep you're going to go in this graph, right? We're going to pull in the whole graph for this person, but what does that actually mean, right? Like if I go to their bank and the bank's got 10 million customers, I'm probably not going to go across the bank relationship. So you'd have to decide. You got to do some scope management. You got to think it out. There's no magical machine way to do this and be like, hey, what's the root objects? Determine them. I could have a person and I could have bank accounts as the top level, or property could be the top level. Like I've got vehicles, whatever it is. So this one you got to think about, and you come back with a complicated object. One way to simplify this is we go one deep. We say, hey, we're going to start at the mother nodes, the root nodes, and we're going to go across any relationship hanging off that to the remote side, and we're going to roll that up. And this will give us something that looks like my reporting view. I'm going to find every relationship hanging off of that person, and I'm going to run a query for each one of those, a graph query where I have to kind of understand it. So I'm going to go person across the billing link, person across the mailing link, person across all the phone number links. And if there were second and third tier artifacts here, we would have to find other root objects and query against those, right? In this case, because we only have one root object, it's easy. So The other way to do that is to just be totally mechanical. And this is actually the approach I've the other two I really like. They feel very sophisticated, and you got to kind of know your data, and you can make this kind of nice query. But they're not very mechanical in nature, and they don't make it easy to massage the data quickly into a format. Now, instead what we can do is we walk away from the notion of a graph extraction, and we do entity-based extraction. And so if we treat all edges and all vertices as entities, so in a relational database, a join is just like this weird foreign key thing. In a graph database, two entities connected to each other are connected by a relationship or an edge that actually has its own properties and is a first-class citizen in the graph. So I vote we do it here. In this case, we're going to run 3 vertex queries, and we're going to run 3 edge queries. We're going to run a query for all the billing edges, for all the mailing edges, and all the phone edges. And then we're going to fetch back all the addresses of people in the phones. So in this case, this would actually give us a denormalized set of tables, in which case the brown ones would be relationship tables with attributes on them. And we do have many-to-many, and because they could be many-to-many joins, well, not even, right? Like a person might only have one billing address. So that would be a one-to-one join table. That's something you don't do in a relational database. But here we treat all the one-to-one and all the many-to-one and many-to-many as join tables. And so we end up with this relational model just doing this mechanically. So if we add a bank account tied to the person, we'll just end up with a bank account table, and we'll end up a bank table, and we'll end up with a bank account edge table, right? For all the bank accounts that join me to that bank. So I think this is where I want to go. We can do this completely mechanically. You got to kind of look at the query language your database supports. But this, to me, this is pretty straightforward. This is actually the approach we're going to take a project I'm on. This is what we're going to do. And then what we'll do is we will take that the normalized view, and we will convert it to a denormalized view for reporting. So either way, I think what we're going to end up with is a 2-phase pipeline, right? We'd either do a graph and then flatten, or in this case, I think what we'll do is we will look at our graph database. We will run a query for each vertex and convert that to a table. We'll run a edge relationship query and convert that to a table. We'll end up with a raw view with one table for each vertex type and each edge type, even if it's between 2 vertexes of the same type. We're going to convert that to a presentation model, which is in the presentation view, and then people will be able to run queries and reports against that. So that's the model that I think is the most straightforward, but you could do the others. If you think the others are better and we should talk about it, then leave me some feedback. And like I said, there are some implementation notes. The work I've done with this has sort of been in Gremlin, and it's pretty straightforward to pull that data back. The only thing I might say is if you're going to do these extracts, remember to add dates to all the vertex and edges so you can get date. If you don't have CDC, then you can get data that changed after a certain time. So that's it. I hope that's useful. Leave feedback. Have a great day.